All right, welcome to this session. So we'll simplify lecture 1 of your course outline, that is the engineering. We are going to actually simplify things for you and also solve these questions, such as this question and also this question. We'll solve all of these questions. All right. Okay. So let's go. So suppose we have the function. Suppose we have the function y is equal to what? 2x, like that, let's say squared. So to differentiate this one, we say dy dx, okay, is equal to what? You multiply this time that will give you 4, then the power minus 1, that will just remain what? 2, like that. So that's the difference, the dy dx of that expression. All right. So now after that, this dy dx of a function can be represented as what? We can say y prime to mean dy dx. We can also say dy dx itself. All right. So we can say dy dx itself. So the other thing we can say, we can also write as what? Dx of a function. Then the other thing that we can also do is we can also write in the form of what? F prime of x, like that. These, they all mean what? Dy dx. So don't get confused. All right. So they all mean dy dx. Okay. So when you come across that thing, then don't get lost. It's one and the same thing. Okay. So let me take you something important. Okay. Suppose we have the range of what? The range of a function, like that, or just a range of what? A measurement. So let's say I have, this is my x1, right? So I'll say this is my x1. Okay. So this is my x1, and this point is what? My x1, like that, just to differentiate the two. So I'm interested, by the way, let me not do this. All right. So I'm interested, this is the what? The value of the other x. Okay, then 0 there. So I want to know the difference or the range of this value from the starting point initial to the end point there. All right, end point. So what I'm going to do is I'll say the change in this one is what we call now the increment, or just the n adjustment or n change of this function from where we started at 0 to this point. We'll actually find it by saying there was a change from this point to that, point, right? So I'll say, so there was change in x. So change in x, I'll say, is equal to what? Is equal to x there, the one I have, minus x, like that. All right, so that's change in x. Okay, then again we can have also something change in y. Let's say I have a point there. All right, I have also point in y there. All right, so if I have point in y, so I can say, let's say this is my y and this is my y1, I don't know. All right, so the change in y as well will be what? Change in y is equal to that if I know y, which is y1, minus what? Just y. All right, so that's a change in y. Okay, so now that we have two equations, these two equations, I want to tell you that we can come up with something interesting. So I'm saying now, I'm bringing the same thing here. So I'm saying change in y, all right, is equal to what? Y1 minus what? Y. So this is in relationship with what? X and y. So we have coordinates like this for x and y. So there's x1 and x2. So if I say this is my x, this is my x what? 1. This is my y, this is my what? Y1, like that. Okay, so these are the points that I have, right? So now saying that, do you know that writing the function y is same as what? F of x. All right, so that is y. So meaning that if, okay, so if I want change in y now, So this is my first x that you are able to see there. All right, so now to say this, I'll say if I want to say y now, change in y1, it will be that just equal to what? F of x1, like that. Okay, so this is what? Corresponding. So what you are going to do is now we'll say change in y. All right, change in y is equal to what? Y1 is what? We said is 1. So we'll write what? Fx1, like that. Okay, minus there what is what? Is what? F of x, like that. Just like that. So this is a change in y and also change in what? In x corresponding to what? To y. So what you are going to do is, after doing this, we are going to say I want to do something here. So what you are going to do is, in terms of since I have what? I have y, I have x1 there, all right, and from my first equation there, all right, I'll say I want to make this x1 we have there as the subject of the formula, so that I go and replace there where there is y there. All right, so what I'm going to do is I'll say change in x is equal to what? X1 minus x, like that. So making x the subject of this one will come that side, so we'll have x1 is equal to what? X, all right, then plus delta or change in what? X, like that. I've just grouped the terms and I've made this one as the subject of the formula. So wherever there's x1 in the y expression, I'll put what? I'll put that. So I'll say change in y is equal to wherever there's that. So I'll put what? I'll put, okay, open bracket, x1 there is giving us what? Is giving us this. So I have x plus what? Change in what? X, like that. Then minus what? F of x, like that. Okay, so that's the function, right? Sure. So this is where now we see that this is just the expression for y, right? This is just for expression for y. So I want to show you something interesting. Okay, so that expression I've made is just the expression for what? For y. I've just substituted for y. Now let's go back to how we find the what? All right, let's go back to how we find the gradient. We know to find the function, we'll say gradient is equals to what? Change in y over what? Change in x. All right, so that's how we find the gradient. So the process of finding the gradient is what we call differentiation. So we have already changed in y, so we also want to see how x will be changing. All right, so what we are going to do, suppose we have the points for change of x. Suppose we have the points like that. Okay, so those are the points we have, and we want to see what will happen. Let's say this is our x, right? Then this, it was what? A certain constant was being added, or a certain number was being added for us to have this final destination. Let's say x plus what? H. The number that we don't know is the constant. Let's say we had this x1 to 1. Then for us to reach this point, for us to, we'll add that constant number which is there. So then we'll add what? The difference there to make what? To get xh. All right, so xh is just a number, a constant number that was added for us to reach at this point. So I'll say change in x, all right, is equal to what? So change in x is equal to what? This initial x that we have minus these guys we have at the point. All right, so we can say a, then this is b. So say change in x is what? Is minus what? A. So this is where we come in to say m is equal to what? Change in y over, all right, change in x is the one I'm doing now. So I had what? I have change in x there. Okay, so change in x is this one, b minus what? A, and b is h plus x, and the a is what? Just x. So very simple. So then what we are going to do is, I'll say change in y is now what? I will replace change in y there. So let me just do with this one. All right, so allow me to write from here. Okay, so change in y, we'll say change in y now. I mean the function will be gotten by saying change of change in y is this one we have there. So we'll say of x, right, plus what, change in what, x, open bracket, minus of x, like that. Okay, then we'll come now down there. All right, change in y we said is what, is this minus what, minus that, or b minus what, a. So we'll say our b there is this one. So I'm saying now b is x plus what, h. All right, then minus the a is what, x just. Okay, so we'll say now change of x that, then plus change in x, all right, is equal to f of x, like that, then over. Okay, so we can see now that plus h minus x, that will just give us what, h, because the x and also this x will cancel. So we are saying now m is equal to what, f of x, x, all right, then plus what, delta x, change in x, then minus f of x, all right, then over h, like that. Is this making sense? Hope someone is not getting lost here. This is just the intro part of mathematics. There's nothing complicated here, so don't get tired. We haven't even done anything. We haven't solved any question. I'm just showing you how to derive this. All right, so I'm just showing you how it is coming about. So it's important that you know where something is coming from. Then from there, then we are saying now this delta h, x, is change in x, and we said change in x will always be h. So you saw that change given was, it has given us h, like that. So also where there is change in x there, we'll get what, we'll also replace what, we'll replace x, h. All right, so we'll say f of x, like that. So we are saying that is the change in x. We saw change in x as the denominator. It has given us what, h. Write h, like that, then minus f of x, like that. Okay, then over there is still the change of what, x, which is h. All right, so therefore we'll say now, okay, so this is what we call now the increment of the function, because everything was changing, right? So the differentiation of a function now at any point, as we'll be having the change in x, as x approaches 0 or any other number, we'll say f of what, f prime of x is equal to what, lim, or lim as h approaches what, 0, then we'll have the function, the same function we have here. All right, so we'll have the function x. So at end point, this is the differentiation of x at end point. All right, so over the change in what, in x, like that. So this is what we call now first principle formula of differentiation. So we can see that this is just the gradient. We are from finding the gradient. So the differentiation, or the process of differentiating, or the process of finding the gradient, is what we call differentiation. So whenever you differentiate, just know that you are trying to find the gradient. All right, so that's the formula now that we'll be using, okay, to differentiate any function. So we'll be given a lot of function, but just know that we'll be using that formula to differentiate those functions. Okay, okay, that is it. So that's about the differentiation of that thing. So there are a lot of things that we can use in terms of differentiating. So sometime we can present something like this. Suppose we have suppose we have suppose we have this function here. All right, I want to show you something. All right, then let's say it is moving like this. Then we have a point there. All right, then we have this point there and also a point there. So what we are going to do is we'll say the point here, this is P, then this is Q. All right, so the point here we can have the point as what, x, all right, comma what, y, which is just f of x. Okay, then at this point we can have x as it changed, we saw how x changes, delta x. Then also there have what, we just put the same delta h to represent what, change in y. So from there then we can see that the gradient of a secant is just right. So this is a secant. So this secant, the differentiation of this one, will subtract this, the initial minus final thing. All right, dx of this secant will be the final y, which is what, x plus what, h, then minus the initial y, which is just fx, then over the final x. The final x is what, plus h, then minus x, which will cancel this and this and will remain with just x. So we'll say f of x like that plus h, then minus f of x like that, over change in what, that's h. So that's also the differentiation of what, a secant. So that's how we'll define the gradient. So that's the gradient. So I can write m, but we use the letter m. So from there then we can also use in delta notation. So when you see delta notation, a delta notation is just also the other way of presenting the same thing that I'm from writing, just the other way of presenting it. Okay, so we might have a lot of stuffs like on how to differentiate. All right, suppose now we have the delta change of a secant. All right, suppose we have a delta of a secant. All right, so let's say we have a point there.